Okay, here we have video notes for the function characteristics that we've been discussing now for the past month and that we're going to use when we delve into functions a little bit more specifically. So our objective, I will be able to determine the slope, intercepts, and equation for different functions. So we've done this before. We're going to call those our function characteristics. So our vocabulary, slope, x-intercept, y-intercept. We know slope is rise over run. We know that slope is called the rate of change. Okay, we have a slope formula. That's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So basically what that means, I'm going to take the difference of my y, so I give you a new kind of symbol here. That's a delta symbol, stands for difference, over the difference of my x's. And then of course we know that if we have a graph, we can use our slope triangle. So the x-intercept, that's where the line crosses the x-axis. When y is 0, we know that x is our x-intercept. Of course, we write it in this ordered pair form. Whatever the x-intercept is first, and then our y would be 0. The y-intercept is where the line crosses the x-axis. So again, that's when x is 0, right there. And of course, when we write it in ordered pair form, y would be 0, and then this would be our y, so I wrote it incorrectly. All right, our first function, when it's an equation form, we know that it has to be in slope-intercept form, so we have y equals mx plus b. b is our y-intercept. So m is our slope from previous learning, and b is our y-intercept. We know that to find the x-intercept, we can substitute 0 for y in the equation and solve for x. Another teeny mistake. Apologize for that. So, here we have an equation. It's already in slope-intercept form. Y equals mx plus b. So in this case, we know our slope is our m, right there, positive 2. We know our y-intercept is b, or the 3. So now to find the x-intercept, we simply have to substitute 0 for y in this equation and solve for x. So 0 equals 2x plus 3, and now we solve that equation for x. So I'm left with negative 3 equals 2x, multiplied by 2, so I divide by 2. So x equals negative 3 halves, or negative 1 and a half. If we were to write both of these in ordered pair form, remember x would be 0, and there's my y-intercept. And here's my x-intercept, and my y would be 0. So there we found the characteristics of this equation, y equals 2x plus 3. If we wanted to, now we can compare it with this function table if we find the same characteristics. So again, we know slope is the difference of our y's over the difference of our x's. So in this case, I can go ahead and find those differences by looking at my pattern on either side. Going from a bigger to a smaller number, and the difference is 3, so that's a negative 3 each time. Over here, I'm going smaller to bigger, so that's a positive 2 each time. So we know slope is, again, that rise over that run. It's that difference of our y's and difference of our x's. So the difference of the y's was negative 3, and the difference of the x's was positive 2, so we know our slope was negative 3 halves. So now I can put that into our equation. Y equals negative 3 halves x. Now to find the intercept, I know that when x is 0, I'm given my y-intercept. Well, here, x is 0. So that must be my y-intercept, or 0, negative 1. So now I can put that where the b was. So now I have my equation, which now allows me to find the x-intercept by following what we did up here, substituting 0 for y, and then solving for x. So, our equation is y equals negative 3 halves x plus negative 1. So let's substitute 0 for y and solve it. I have to get rid of the negative 1 by doing a positive 1 on both sides. That cancels. So 1 equals negative 3/2 x. We know from previous learning that when I have a fraction in front of a variable, I multiply by the reciprocal. So that means I flip it. Remember to keep it negative. I do the same thing on both sides. So negative 3/2 cancels with negative 2/3. So I'm left with x equals, let's make them both fractions. Negative times a positive is a negative. 2 times 1 in the top, 3 times 1 in the bottom. So my x-intercept is negative 2/3. Or if I were to write it in ordered pair form, negative 2/3, 0. So again, if I were to compare these two functions and ask you which has the greater slope, now you could say that 2 is greater than negative 3/2. So if we were to graph both of these, this function would have a steeper graph than this function. All right, let's go to an actual graph then. Here we have a linear function, makes a line. So we know that we can find the slope of a line because it's rise over run, and we can use our slope triangle. Should remember that from our vocabulary earlier. So let's go ahead and make our slope triangle. As long as I have two identified points, I simply make a right triangle. So I can go from here, up and over, or I can go from here. We know from previous learning that the smaller triangle, even though it's similar to the larger one, is the best one to use because we won't have to simplify. So in this case, here I went up 1, 2, 3, 4, and over to the left 1, 2, 3, 4, 5, 6. So that's 4 over negative 6, or negative 2/3. I had to simplify. Whereas here I could just count up 2 and over 3 to the left would be our negative 2/3 without having to worry about simplifying. Then we know our y-intercept is where we cross the y-axis, so that's right there. So that's going to be a positive 1, or in ordered pair form, 0, 1. Now, to find the x-intercept, remember I have to have my equation. Although I could look, it looks like my x-intercept is somewhere between 1 and 2, maybe like 1 1/3 or 1 1/2. If I had a multiple choice question, I might be able to answer that, because one of the answers would be close to that. But this is free response. I don't know what that is, so I'm going to have to do it mathematically. So our slope-intercept form for this function is y equals, there's my slope, negative 2/3 x, and there's my y-intercept of 1. So now I can substitute 0 for y and solve for x. So do negative 1 on both sides. So negative 1 equals negative 2/3 x. So just like the problem we just did on the last page, I have a fraction in front of a variable, so multiply by the reciprocal, so flip it. Remember to keep it negative. So negative 2/3 cancels with negative 3/2. So I'm left with x equals, well, a negative times a negative is a positive. 3 times 1 in the top, 2 times 1 in the bottom. So 3/2 or 1 and 1/2. And in ordered pair form, it would be 1 and 1/2 and 0 for y. So again, we could compare these characteristics with the characteristics on this page. This equation still has the largest slope compared to these other ones. So finally, we have a verbal description. It says, Jared pays a usage fee of $20 every month and then 10 cents per minute for his cell phone. How much is the bill this month if you use 200 minutes? We know that we can write this verbal description as an equation in slope-intercept form. We again just need the slope and the y-intercept. Well, we know slope is the rate of change. That's going to be that rate where we have the same thing happening over and over and over again. So that generally is the part that gets multiplied, or the per part, right here. In order to figure out your cell phone bill, you multiply your minutes times how much per minute. We know that the y-intercept is the original loan, or what you have before you start multiplying. In other words, what do I do just one time each month? Well, that's pay this $20 fee. So that's your y-intercept. So again, we go up here for slope. We know that we're going to pay 10 cents for every 1 minute. So our slope is simply 0.10 or 10 cents. So now I can write my equation in slope-intercept form and again substitute 0 for y to find the x-intercept. So here's my equation, y equals, there's my slope. Okay, in real life you can have decimals, so that's 0.10 x plus I know I'm going to pay $20 one time at the beginning of the month, even if I don't use my phone. Now if I wanted to write it using labels that made more sense, maybe my y suddenly becomes my B for bill, my total bill, and then my x becomes the number of minutes I use. And then we still have our $20. So sometimes labels are important, especially if I were to graph this. Okay, if I were to sketch a graph, this would be my total bill, and this would be my number of minutes. And then I could graph it, and still I could find my slope-intercept this way. It's just faster to do it mathematically now. So let's go ahead. Substitute 0 for y equals 10 cents per minute plus $20. So let's solve it. Got to get the 20 up to the other side. So I do a negative 20. So I have negative 20 equals 0.1. And I'm going to get rid of this 0 because I don't need that decimal 0. Okay, I'm multiplying by 0.1, so I divide by 0.1. They cancel, so I'm left with x equals. So a negative times a positive is a negative. And then 20 divided by 0.1 means I move the decimal over. So I have to move it over here and bring it up. Add that 0. And now 1 goes into 200, obviously 200 times. So x is negative 200 in this instance. So, in other words, we found the characteristics of an equation, of a function table, of a graph, and of a verbal sentence. And now if we wanted to, we could compare them all together. Good luck. Make sure that you take the Edmodo quiz to get credit for this.